Hey guys, so I just wanted to make a video to kind of go through the notes that we did after the test this week. Okay, so during class, we didn't have a ton of time, only about 20 minutes after you guys were finished with the test. But these are really, really important notes, especially for your e-learning on Friday. So I wanted to kind of record this. That way you have the notes. We will talk about them again on Monday, so don't worry about that. But I'm just going to kind of go through them as I would have in class if we had enough time. Okay, so the whole idea is polygon similarity, okay? That is our next standard. So that's outcome number 8. Remember, there are 12 outcomes in this class. So what you guys are going to do is you're going to use proportions, which you have done for e-learning before, so where you solve proportions to identify whether or not two polygons are similar. So first of all, remember that polygons just are shapes. That's just a fancy word for shapes. Okay, and then we are going to look at some vocab that will be kind of a review for you guys. So corresponding angles is something that we have seen before. Those are angles that occupy the same relative position, which is really, really all that you need to remember about them. So they occupy the same relative position. Corresponding angles are going to come up a lot throughout this whole topic, this whole outcome. And then the other word that's super important is congruent. So that's just two angles that are the same exact measure. So they're the same angle, meaning like if one is 60 degrees, the other one is 60 degrees. The new vocabulary that we need to go through is similar polygons and scale factor. So I'm not going to talk about those yet. I'm just going to dive right into an example because I think it's easiest to learn this stuff with an example. So I'm going to go to the next page, and we're just going to look at number 1. So the first example. So it says list all pairs of congruent angles for the figures. Okay, so what I want you guys to write on your notes is that for two polygons to be similar, two things have to be true. Number 1, corresponding angles have to be congruent. Number 2, corresponding side lengths are proportional. So the two key words there are congruent and proportional. When we are deciding whether two shapes are similar to each other, we have to check that their corresponding angles are congruent and that their corresponding sides are proportional. So when this question says, list the pairs of congruent angles, we are looking for the angles that correspond with each other. So this statement right here is called a similarity statement. And it says triangle ABC is similar to triangle DEF. That little squiggle line right there, this little squiggle, just means similar. So it means that these things are true for these two shapes. All right, so remember, corresponding angles just means two angles that occupy the same position. So down here, we're going to write our pairs of congruent angles. So I'm going to start with angle A. Well, angle A looks like it corresponds with angle D. Those are both in the bottom left of the triangle. However, you do have to be careful. Naming matters with this stuff. So in other words, the way that the triangles are named makes a difference. So if we look at these two names up here, so let me use the laser pointer. It's triangle ABC and triangle DEF. So angle A is listed first and angle D is listed first, which is why A and D are partners. Now, thankfully, in this diagram, I can visibly see that A and D are in the same position. However, it's possible that this triangle would not be drawn very nicely. It's possible that I could have drawn it like this instead and put F here and E here and D here. I'm allowed to flip it. And then you might accidentally say that A and F are partners. So you have to go back to the name. So B and E are both in the second position. So I'm going to say angle B and angle E are partners. And then C and F. That's how we decide what our congruent angles are. So these are corresponding, which means they must be congruent because I know that these two shapes are similar. Next, we have to look at the side lengths. It's the exact same idea. So we're looking for corresponding side lengths. That means I'm going to look at each side one at a time. So if I'm going to look at AB first, okay, here's side length AB. From the picture, it looks like it's partners with DE, right? They're both on the left side of the triangle. We do need to double check, though, that that is the case based on our naming. So if you guys look, AB are the first two listed and DE are the first two listed. Those side lengths occupy the same position, so they are partners. So I would say down here that side AB, AB corresponds to side DE. Next, I'm going to look at BC. So when I go up here, I'm going to look at BC. Again, from my picture, it looks like it would go with EF, right? They're both on the right side of the triangle. I need to double check with my name. So here's BC, it's the last two letters of the triangle, and here's EF. They do occupy the same position. They're both the last two letters, so they are partners. All right, so down here, I'm going to write BC corresponds to side EF. And then my last one would be side AC with what? So if we look in this first triangle, side AC is on the bottom, right? And side DF is also on the bottom. So they have to be partners in this case because we've already used the other two pairs. If you looked at the naming, A and C are the first and last letters, and so are D and F. So they do match up based on my naming. So this was a nice one because the picture matched the names. It won't always be that nice. So be careful and make sure you look at the way the triangles are being named. Okay, so AC would correspond to side DF. The next thing says, write these statements as proportions. Proportions are just fractions. Okay, the side lengths that correspond to each other are partners. They're going to go in the same fraction. So I'm going to write AB over DE. Another one would be BC over EF, and then AC over DF. Those are my three proportions, okay? Because these two triangles are similar, the corresponding sides are supposed to be proportional. Being proportional just means that the proportions are equal. The fractions are equal. So that means down here, I'm going to write an equal sign in between these three proportions. So AB over DE should be equal to BC over EF, which should be equal to AC over DF. That just means that whatever the numbers are on the sides should make equivalent fractions. They don't have to be the exact same numbers, but they have to simplify to the same fraction. And we're going to look at an example of that on the next page. So the whole point of proportions is that the fractions are equal. So if two shapes are similar, the corresponding side lengths should be proportional. Okay, so let's look on this previous slide. So we saw this right here is a similarity statement. An example. Number 2 right here, this is one that I did in class with every class, I think. We have two shapes. They are named DEFG and JKLM. So this is another one where they are actually drawn the right way. So we have DEFG on the left and JKLM on the right. We are deciding, are they similar? So we don't know if they're similar. That's what we're going to figure out. So with this question, we have to think back to our definition of similar polygons. There are two things that have to be true. So if you remember, one of those things is that the corresponding angles have to be congruent. Remember, that just means the corresponding angles have to be the same measurement. The second thing we need to check off is that the corresponding sides are proportional. In other words, when we get the fractions from our corresponding side lengths, those fractions should be equal to each other. Okay, so let's just check the angles first. That's always the easier one to check. So I know based on the names DEFG and JKLM, angle D is partners with angle J. So D and J are buddies. If you look, there are 3 little tick marks on D and 3 little tick marks on J. So D and J are good. Those are congruent. So I'm going to kind of write that right under here. D and J, check. Now I'm going to use a different color, and I'm going to show you guys E and K. Okay, so I know that E and K both occupy the second position of their name, and I can see from the picture that they are in the same spot. We don't always get that lucky, but we did this time. So if you notice, this time, angles E and K both have 2 little tick marks, which tell me they're the same size. So E and K are good. Next, I'm going to look at the third angle listed, which are F and L. So F and L occupy the same position, and they both have 1 tick mark. So those are also the same. So F and L are good. And the last one I need to look at is G and M. If you notice, G and M both occupy the last position of their names, and they're in the same spot in the picture. And they're both right angles, so I know they're congruent. So G and M are good. All right, so what we just did was we made sure that the corresponding angles were all congruent. Now we have to do the harder part, which is looking at the corresponding side lengths. All right, so the corresponding side lengths. Well, we have DE. Let's just start at the beginning. DE, which is the first 2 letters right here, and JK, which are also the first 2 letters. So I know that I'm going to have DE over JK as one of my proportions. Okay, so now we have DE and JK. I'm going to look at the next one. I just kind of go in order of what I see. So next I see side length EF. All right, if I look at my name up here, I can see that E and F are the 2 middle letters. So I want to look for the 2 middle letters in the other name, which is KL. And I can also see that those 2 look like they're corresponding. So now I'm going to write equals EF over KL. Because remember, I'm deciding whether or not they are proportional. So I'm going to initially write an equal sign. If they end up not being equal, then I know that the answer is no, they're not proportional. So no, they're not similar. So initially, I always just write an equal sign. All right, next, I'm going to look for what corresponds with FG. Okay, so here is FG down here at the bottom. If I look in my naming, F and G are the last 2 letters, and then L and M are the last 2 letters. And that looks like it matches up with my picture also. So now I will write equals FG over LM, which equals, and my last one I'm going to do is GD. So I have GD right here, and again, I just go in order. I can see that G and D are the first and last letters of the name. And then M and J are the first and last letters of their name. So MJ is also highlighted. All right, so then I'm going to write equals GD over MJ. Now that I know which things are partners with each other, I'm going to plug in my numbers. And if you are comfortable just plugging in the numbers from the get-go, you don't even have to do the step that I just did. So you could have initially just said, well, I know DE is 15 and JK is 20, so that's 15 over 20. All right, then EF is 6 and KL is 8. Then I've got FG, which is 12, and LM, which is 16. And GD is 9, while MJ is 12. So I have my 4 fractions. I need to see, are they actually equal to one another? So I know, because I've done this problem before and because I'm very comfortable with fractions. However, if you're someone who doesn't like fractions, they're not your friend, that's okay. You can just take these and plug them into your calculator. So plug in 15 divided by 20. I get 0.75. So I'm going to write 0.75 underneath it. And then I'm going to plug in 6 divided by 8. I also get 0.75. 12 divided by 16, 0.75, and 9 divided by 12, also 0.75. So because those fractions all ended up being equal, I can check off step 2. I checked that my corresponding sides were proportional. Okay? Now, if you notice, this question says write a similarity statement. Okay? A similarity statement is like what we... So it's just saying triangle or shape blank is similar to triangle or shape blank. So we just said that shape or polygon DEFG is similar to polygon JKLM. We figured that out by our checklist. So I'm going to write DEFG, put my little similar squiggly line, and JKLM. That's a similarity statement. It's just saying they are similar. I know that because I followed my checklist. Then it says to find the scale factor. The scale factor, like I said in class, if you think about a map, so if I had a map of the United States and I looked at Indiana and I looked at Florida, Indiana and Florida are thousands of miles apart, right? However, on a map, it's probably only a couple inches. So the scale factor would be like 1 inch equals 1,000 miles or something along those lines, right? It depends how big your map is. So a scale factor is basically just telling me, how do I convert from one thing to another? So in other words, in this case, it's asking me for the scale factor from DEFG to JKLM. All right, what's true, and we found this out because the corresponding sides were proportional, is that to get from each side length on DEFG to each side length on JKLM, we're going to multiply by the same number. Notice how we got 0.75 when we looked at our fractions, our proportions. That is a scale factor. However, and this is what you should write down, the scale factor from something big to something smaller should be less than 1. So this scale factor of 0.75 is actually getting us from the bigger shape to the smaller shape. So that means if I took side length JK and I multiplied it by 0.75, it gives me side length DE. It gives me 15. A scale factor from something small to something big has to be bigger than 1. That's the difference. Okay, so to get from DEFG to JKLM, I need to use the reciprocal of 0.75. A reciprocal just means I'm flipping the fraction. So if you think about what is 0.75 as a fraction, well, it's 3 over 4. So the scale factor from the bigger shape to the smaller shape is 3 over 4 or 0.75. I need to flip that so that way it's bigger than 1 if I want to get from D, E, F, G to J, K, L, M. And that becomes 4/3. So that's how we do scale factor, okay? So whatever you get for your scale factor, pay attention. Is it less than 1 or is it greater than 1? And use that to apply it to the question they're actually asking you. And I know right now that sounds a little confusing because we didn't talk about it as much in class. We will talk about it a lot on Monday/Tuesday next week. All right, so now that we are done with number 2, I'm going to show you guys how to set up number 3. So number 3 is a question that tells you these two shapes are similar. So you're not deciding whether they're similar or not. They're already telling you, hey, these shapes are similar. So remember, that's what this symbol means. Then it says, find the value of x. All right, so what do we know if two shapes are similar? Well, 1, we know that their corresponding angles are congruent. And 2, we know that their corresponding side lengths are proportional. Okay, in this case, we don't really care about the angles. We're just gonna assume that they work, that the corresponding angles are congruent. What we care about though is the side lengths. We know that the side lengths are proportional, and we know that because it says they're similar. Okay, so we need to set up our proportions to find the missing side length. All right, so AB is partners with PQ because of the naming. So we have AB over PQ. And we know because they're similar that all proportions will be equal. And then we know that BC would be partners with QR, again because of the naming. So that's BC and QR, which only leaves CA and RP. So CA and RP. Now I'm going to start plugging in numbers. So this is how I would always do a problem like this. Set up your proportions, plug in your numbers, decide what you need to solve for. So AB is 14, PQ is X. BC is 6, and QR is 9. All right, I'm going to stop right here because at this point, I can already solve for X. We're going to solve for X by cross multiplication. So you're going to do 6 times X and 14 times 9. So then we would get 6X equals, and then we'll do 14 times 9 in our calculators. So 14 times 9 is 126. We'll solve for X by dividing by 6 on both sides, and then X equals 21. So that was just asking us, what does X have to be in order to make these things proportional? Once you have at least 2 fractions and only 1 variable, you don't even have to worry about the third one. Okay, so I'm done already with that problem. Previous page, it tells me that they are similar. All right, I'm just gonna see what is on the next page. So this page is essentially the same exact thing. Number 4 asks us to find a scale factor though. So it says find a scale factor of RST to XYZ. Okay, so I already know they're similar. I have to find a scale factor. There is a missing side, but I don't really care about it. I just need to find a scale factor. So we've only done scale factors once so far. I just talked about it once. It says from RST to XYZ. So when you're finding a scale factor, I'm just gonna call it SF. I would say your first step is to identify whether you're getting bigger or smaller. So from RST to XYZ, are my side lengths getting bigger or smaller? Well, they are getting bigger. So identify bigger / smaller. Okay, we did that. So I'm going to get larger. That means that my scale factor is bigger than 1. So if it was getting smaller, then my scale factor would be less than 1. And you'll see a question that asks you about that on your homework. All right, so all I have to do is set up my proportions. set up my proportions, and find what they all simplify to. So I have 45 over 50 because RS and XY are partners. So 45 over 50. And then I have 27 over 30 because ST and YZ are partners. I already know that those two things are equivalent because they told me that they're similar. So I know the fractions have to work out and be equivalent. I don't care about the third fraction. It really doesn't matter yet. It's kind of irrelevant to me because I already know that they're all equivalent. So I don't have to worry about it. So I'm going to see what is 45 divided by 50. So 45 divided by 50 is 0.9, which is 9 over 10. That is the common factor. And then I will double check that 27 over 30 is the same thing, and it is. Okay, so if I said my scale factor is 9 over 10, but I'm getting bigger, that wouldn't work because 9 over 10 is smaller than 1. So I have to flip it, and my scale factor becomes 10 over 9. That means that each side, when I multiply it by 10 over 9, I'm going to get the side that's over here. So just experiment with me. If I take 45 and I multiply it by 10 over 9, I'm going to get 450 over 9. So 450 divided by 9, which is 50. So that scale factor just tells me what do I have to multiply each side by to get the sides on the other shape. So to go from XYZ to RST, it would be 9/10 because I'm getting smaller. So remember, getting smaller means it's less than 1. Getting bigger means it's greater than 1. That's where I'm going to stop on these notes. You do not have to fill anything else out. Just kind of write in what I wrote and then turn these notes in if you haven't already. So I will upload these. And if you have any questions after this, please send me an email.